Today, I will be your moderator. My name is Brett Little, and I'm the executive director here at the nonprofit, the GreenHome Institute. And really what we're going to be talking about is how does modular construction tie in with the green building movement, and what benefits are there by going modular, and then what connection is there if you're pursuing LEED certification? Can there be any connections between the two? Before we get started, a huge thanks to our top tier sponsor, Build Equinox, featuring their new Serve 2 smart ventilation on-demand system. Unlike traditional ERVs or HRVs, it features many qualities of smart balanced ventilation and feedback monitoring as well. With standard HRVs or ERVs, you get a constant low airflow rate with no relation to actual indoor air quality or occupancy for that matter. For the first 3 days in this study here, when the home is occupied, the air quality is poor. The ERV just can't keep up. When the occupants leave on vacation, the ERV keeps ventilating and wasting energy. There's no one there. Since the Serve actually monitors air quality, it ventilates only when it needs to. Compared to an ERV, the CERV can ventilate up to 300 CFM quickly, purging pollutants from the home. When no ventilation is needed, the Serve can recirculate and unify the home, providing some additional heating, cooling, dehumidification in an energy efficient manner. The Serve does this by monitoring both CO2, volatile organic compounds, humidity, you name it. Something that you can't smell, this system is detecting throughout the house. And instead of an ERV exchanger core, the Serve has a high efficiency heat pump which exchange energy between incoming supply and outgoing air. What does this mean? It's conditioned, comfortable air that unifies the home instead of dragging the exterior rooms away from comfort. And these systems now can have a MERV 13, which is very important to prevent viral transmissions. Serve is manufactured right in Urbana, Illinois, in a 100% solar powered facility. And it can link up with things like the Rheem heat pump to help boost it. It can sync very well with Mitsubishi's mini split systems that we've seen around homes to help distribute air. And it has a geo boost function, so it can work really well with water furnace to improve geothermal systems. Check it out over at Serve2 on buildequinox.com. And thanks to our second tier sponsor, Ava Windows, who's got R7 windows as well as aluminum ones with recycled content. Thanks to their support. With that, Ken, I am going to hand it off to you in a second here. Got my slides mixed up as I was building them out this morning. Ken Semler, very excited to have him on the call today. He is a licensed, certified, registered builder in 42 states. He is the president and CEO of Impressive Modular. His company uses off-site construction to perform residential, light commercial, and multi-family construction. He works throughout a network of 20 factories to deliver projects across the country. He is the immediate past chair of the National Association of Home Builders Building System Council and is currently an officer board member in the Modular Home Builders Association. Ken takes a leadership position in the off-site construction industry and frequently speaks at conferences such as the NAHB International Builder Show, and provides training to support the industry. So Ken, we're very excited to have you on today's call. I'm going to hand it over to you, and please take it away.
Okay, thank you. Thanks, Brett. Hopefully you're seeing my screen now.
Yes.
Brett's kind of taken some of what we were going to talk about here to start out. He's given me a great introduction. We can skip this slide. Brett also did display what we're looking to accomplish in this webinar today. Overall, we're really going to talk about how modular construction can meet green requirements and support your building to green labels. What I want to do first or accomplish first in this is really what is modular construction. There's a lot of confusion. Talk about some of the benefits of modular construction, and then we'll identify what the components of green building are, and then we'll go into detail about how modular construction can enhance your green building. And then we'll get to questions at the end. I think also I'll identify we would like to have this be conversational to some degree. So there should be a chat box that you can type questions into as we proceed. If you have questions, Brett will act as the moderator. Please put the questions in. He'll stop and ask questions as we go throughout the presentation. So first, what I'd like to talk about, what is modular construction? And I guess one of the key distinctions, and a lot of people think it's minor, but it really isn't, is modular is a method of construction. It's not a type of house or class of structures. So what will happen is we get a lot of confusion with the term modular home, mobile home, manufactured home. And those mobile homes, manufactured homes are built under a separate building code, something called the HUD code, the federal code, and they're built typically the same throughout the country with a few modifications for temperature, for zones of temperature and wind zone. But the modular is actually built to the standard, the same standard, same building code as every home built in the local area. And the National Association of Home Builders identifies it along as one of 4 building types of systems. We have modular, we have concrete construction, we have panelized construction, and log and timber. One of the key aspects, and we'll go into this in much more detail as we talk, but modular is actually built indoors. A big thing that we'll also talk about is inspected for quality and code compliance. And because people don't understand the process, if I build it in a factory and I ship it to a location, how does it get inspected? How does the insulation or the framing inspection get done? The next thing we'll talk about and go over is these modules are built in pieces. A house is broken down into modules. It's built in modules, typically 14 feet wide, 16 feet wide, up to 76 feet long. They're delivered to the job site, but each module in and of itself is basically a complete or mostly complete module of the home it's going to be assembled into. So these are just examples. A lot of times I'll ask in a presentation which one of these are a modular home, but I'm going to cheat and just, tell you up front, all of them are. I think we have a lot of people that have misconceptions of what we can do. I have people ask me, well, how big of a home can I build with a modular home? And I liken it to Legos. How big of a Lego set do you have? We're building all the modules. We're assembling on site. I can build a 600 square foot home. I can build a 2,200 square foot home. I can build a 10,000 square foot home. We can build just about every type of home. You'll see from a contemporary to to more traditional 2-story and everything in between. We can build value. We build multi-million-dollar modular homes. We build simple backyard cottages. The first thing I want to talk about is in the factory. Is a lot of people don't understand kind of the process, and it really is what we've done with modular construction is we've taken construction and turned it into a manufacturing process. So a factory is a manufacturer, it's not a builder. And so, but it's got very efficient at making these modules. So for example, in this slide, assuming that the bottom row, the bottom set of squares, that's really a production line. And you're seeing where, imagine, we'll see just in a minute some pictures, you're going to see where we start out building the subcomponents. So in the top left-hand corner, we're creating subassemblies of plumbing and electricals getting installed right after the flooring and the walls are being put together. As the module moves down the assembly line farther to the right, drywall is being installed, potentially exterior OSB after the insulation is going in. Floors, walls, and ceilings are framed and they're drywalled at least on one side to the top part to the subassembly area at the top middle of the screen. So again, you'll get a better idea of the flow as we start seeing pictures. But a factory, typically a factory is an assembly line, not a moving assembly line, but it moves from left to right in this example, and to the side, subassemblies and subcomponents are being built. Sometimes it's a subassembly being built into a larger assembly, which is then assembled on the line. And that's how we get our efficiencies with modular construction. So some of the big benefits of modular construction are being built in a factory is the improved quality control. In the field, very little is done with a third party to go out and do the quality inspection. And we'll talk a little bit more about this later, but in the process, we're not only doing code inspections in the factory, we're doing quality inspections in the factory. And we'll talk about this, but it's really an economic advantage to the factory itself. If I can fix it for $1 while it's on the line, if I can fix it for $10 while it's out in my yard, or it's going to cost me $500 to send 2 guys to the site to correct it, the factory's financially, incented to make sure it's correctly done in the factory. And so that's where they're doing a lot of their inspections to make sure it's done right. We'll talk more about the improved labor productivity. But labor productivity is huge right now. We don't have the skilled people in the workforce to draw from. Keep in mind, factory production gives me a big advantage because I can take unskilled labor, bring them into the factory in one centralized part that'll work on many houses, and I can use unskilled labor that I can train. Once I train them, I can supervise them to make sure they're doing it right, essentially turning unskilled into skilled labor, and then I can inspect it to make sure they did it right before it got into the field. A lot of aspects here. We talk about enhanced indoor air quality. Factories are clean environments. When we build a module, we build the floor. One of the first things we do is we lay down plastic to protect the floor. So as drywall work's getting done, as dust is getting done, none of that dust or those particles are getting embedded into flooring, into other areas. And at the end, all of that gets pulled up and we have a totally clean floor as just one example. We'll definitely talk more about building energy efficient structures. We'll go into more detail later. Improved materials management. The waste reduction is going to be a big thing we'll get into, and just better overall material efficiency. Now, what I will add here is keep in mind throughout the United States, there are multiple factory capabilities very widely across the country. And as a modular builder in 42 states, working with actually over 20 plus factories, each factory has various capabilities. In the Northeast, we tend to see very, if I want to do any type of project, it's more of an insert tab A and slot B process. They will build it. Earlier in one of the slides, I had talked about hybrid construction. Hybrid construction is actually taking the 4 building systems recognized by the NAHB and combining them. So we might build modules in the factory, combine it with panels built in that same factory, or maybe even structural insulated panels, SIPS panels, and do a combination or do a hybrid house in the field. This is just an example. I really want to draw the comparison between site-built construction or on-site construction versus factory-built or off-site construction. And so these are just some good example pictures of what you see when you're building in the field. And so a lot of people like to say, my house is stick-built, so it's better than a modular home. Well, the fact is, modular homes for the most part are stick-built also. They're just built off-site in a factory and brought to the site. But as you'll see in this top left-hand picture, I mean, do you really think that you can take and cut every stick that you're putting into the frame of the house to the exacting standard while you're trying to do it on the ground, in the heat, in the cold, in the wind? So we're just showing the example. I like the example on the right that you've got men trying to stand up a wall that they've nailed or on the slab. Well, now that's wobbling, that's moving, and they're trying to get it stabilized and get it to stand up. And then we all know it's going to rain eventually, and this is what happens in that middle picture. And now that moisture is getting into the floor, into the walls, and everybody's in a hurry to build today. For example, I personally took that picture in the middle of a friend of mine that site builds, and it was his house. He got up, the walls were up, he got everything done, the trusses didn't get in, and the water came down. That's the way that's set. That house in the bottom left, I took that picture too. Had a rainstorm right at that point. For 2 weeks as they were closing in that house, water puddles laid on the floor of that house, and nobody swept them, cleaned them, dried them. The water puddles laid in that floor as that house got closed in. That's what's happening in a lot of your production, semi-production building. That's what's happening in off-site construction. Bottom right, again, just a sample. Your people are trying to get trusses up because the equipment couldn't be on site, and things aren't just getting done as perfect as they should. With modular construction, it's in a factory. I mean, there's a huge difference between that previous slide and what you're seeing on this slide. I know it's kind of a collage here, but just start at the left-hand side. What you're looking at there is an interior partition walls. Just a little bit in the background of that picture, you'll see a jig where some walls are being built. It's set up to be ergonomically. We either do it indoors with automation, jigs, or basically training and building on a level floor. And so those jigs, you can stand at the top, stand at the bottom. You're nailing things perfectly as you do this because you don't have to be reaching. It's good enough isn't good enough. But those walls are built, they're stockpiled, they're numbered. You'll see the top middle slide as they go down, the floors are assembled, and it looks like a 3D drawing like you would do on a CAD system. You're seeing everything get assembled. You're seeing plastic on the floors. As those modules start to move down the line at the top right slide, you're seeing a roof assembly that's been built on a jig table on the second level and a mezzanine at the far right. The long walls on that bottom left of that picture, you'll see a jig table that builds those long walls. So we're taking the plan that we modularized and we're starting to assemble it piece by piece with the walls. Pretty soon, insulation's done, roofs are typically being assembled, sheathing is going on, shingling is going on, to where it gets to the end of the production line and it's ready to go out the door with all the insulation completed. The roofs are basically assembled and fold down roofs. And it's really like an origami roof or a kid's transformer toy. The roof is assembled so it automatically pops up, flips go over, eaves flip down, gable panels pull in, and we have a roof. It's all built for speed and energy efficiency. The big part I would like to talk about that happens on site more than off site is that off site there actually is about half the country has no building inspections in the counties, and you don't know if you're getting a house that was built to meet building code or not. But at a factory, every state has actually requires, most states actually approve in Michigan, Ohio, to some degree Rhode Island, Colorado. The state actually approves theirself the plans for the modular factory to build the modular units. In other states, they've given that authority to a third party, and that third party could be a company like a PFS, a TRA, and an NTA. There's more than a dozen of them that work with modular factories. They basically get the plan, approve the plan, stamp the plan, and then they're responsible for inspecting it in that factory. So that's usually set up for efficiency. That's set up in systems. So when a new modular factory is created, they define what their systems are, what a wall assembly will look like, what a roof assembly will look like. And as we're defining a home or designing a home, those assemblies get plugged in as components. And so that for the third-party inspections, we're using systems that are already predefined. So they're doing a review to make sure the factory implemented them correctly. If we're doing custom homes, we might have to implement new systems as we design what those homes are going to look like in a factory. But the systems are documented. There's consistency and compliance audits at the factory to make sure they continue to use those systems. At the factory, we tend to have a more consistent workforce, so they're working with the same people at these third parties to ensure we have quality and it's being done correctly. And there's also a feedback loop because we have a system in place. If things are getting out of the factory that aren't being done correctly, as the service department works and finds those, they have a feedback loop back into the server or the production department to make sure things are getting corrected to be in compliance. So this is just a quote from the NAHB Research Center that site-built housing is not subject to nearly the same degree of design review as manufactured or modular housing, nor do site builders have to adhere to formal programs that demonstrate the construction process incorporates accepted quality improvement and control procedures. I will tell you that the package in many areas that a modular builder submits to their building permit office might be 2 or 3 inches thick, because it's every system, how we do it all the time, how it's done consistently and correctly. And the local site builder might just be submitting 3 pages, 8 pages, 10 pages. Typically, modular construction is held to a much higher standard than site-built construction when it comes to permitting in the counties that do. But one of the big things, go ahead.
Oh, it looks like you might be answering it now. Somebody had a question about permitting time and whether it gets sped up, so continue.
So well, and that's actually a good question. We'll get into a little bit here, but so it's really different by area and county. And because we work in 42 states ourselves, it really does vary. In some communities, they ask for so much because modular is new to them. And our experience has been, especially when you're a local builder working in a local area, you get familiar with your local building department and plan reviewers. I have some areas that the plan reviewer loves modular because guess what? A third party reviewed it and stamped it. It's done at the state level, which supersedes the local level. So we just did 2/3 of his work for him. He can take that stamp plan, everything under that stamp, and that gets set to the side. the things that he's doing locally are the foundation, decks, porches, things like that weren't done at the factory. He's responsible for that, but he's not responsible for the factory portion. So it does, to the question that was asked, it will speed up the plan department if they're familiar with modular, and there will be some potential training opportunities depending on how your local building department wants to work with offsite construction. But what we were getting to here was really the speed up in modular construction. A lot of people will ask, how long does it take to build a home in the factory? And I will tell you, it really does depend on factories, because like each geography has some assembly line, which we'll get into. Some are more build installs. But what's really happening is we are taking about 8 weeks from the time that house gets off the assembly line or starts in the assembly line to it gets built by the parallel processes you're seeing here. Site prep and foundation is happening at the exact same time that modular construction is taking place. The house gets delivered to the local site. Now, I'll tell you, it's not a surprise. The modules just don't show up one day. This is a different planning process, and that's the biggest part of the learning curve is the resources, staffing, and doing basically schedule management, project management. Is I have to have the modules delivered, the crane show up, an installation crew show up. The houses usually get delivered on one day. The house starts being set the following day. In 1 to 3 days, that installation on the foundation's done. Here you'll see we start to do exterior finish, we start to do interior finish, and in a period of 8 weeks, this house is done. Having said that, there is a planning process up front that has to get done because we have to have it all decided, colors done up front, and so it does take a little longer up front, but we speed through the process once we get going. Now, this is in comparison to a site build process, which is sequential. We can't do anything parallel because I can't start putting the floor on the site until the foundation's done. I can't start doing the foundation until the site prep's done. So you'll see in comparison, everything's happening sequentially in site built construction. And according to the NAHB studies, the average site built home takes 19 weeks to complete. And you'll see at the bottom, the average modular construction takes 8 weeks to complete. We'll just go through the components of green building. We'll talk now a little bit about how modular construction can help really build or enable green construction. And so we'll talk about the energy efficiency and renewable energy aspects, waste reduction, the building materials and the use of the building materials, water efficiency, toxics reduction, indoor air quality, and we'll touch to a little bit on the smart growth and sustainable development. So the first thing is the energy efficient structures. We talked about this earlier, is when you're building in the factory, we're actually doing things in a very systematic way. So for example, we're taking and building the headers in a sub-assembly area. We're taking those headers, putting them into a bigger wall assembly. Then that wall assembly, whoops, jumped ahead. That wall assembly is being installed on a floor system. That floor system, before we put it on, we're sealing or putting a weather strip or a caulk in that before we place it on that floor system. But every assembly is precision built as it moves through the process. It's not somebody standing out in the field trying to nail a wall together on a slab and then standing it up wobbly and trying to do it. Everything is done with booms and cranes. You're not stressing walls. Everything is really done tight in the factory. It is, as it says, a controlled manufacturing environment. We're building to systems. These systems are predefined. The employees, the staff, the workers in the factory are used to doing the same thing. They have a process to do it. It doesn't vary. We'll see that in a next coming slide. Because we have the feedback loop, and if we have any issues, we might have it go wrong one time, but we have the ability to fix it so it doesn't become a systematic problem. We do support for renewable energy. Now, typically with the renewable energy, if we're prepping at the factory, what we're doing is usually we're not doing, say, for example, solar in the factory. We're working with a solar company that will be doing things on site. They will tell us if we have to do, say there's additional requirements for solar on the roof for structural support, that will have been decided ahead of time, so we know what we're adding to the roof. We're installing the conduits. We're making sure of our electrical availability or the boxes sized correctly, and we're prepping for the solar to go in on the site. One of the things that with the most green programs, there are points awarded depending on the program itself. You know, I know I was discussing with Brett previously, you know, with the LEED program, how points are awarded and how that can happen because you are building actually in the factory and you get credit for that. This is another variation. When you're doing modular construction, and like I said, based on where you're at in the country, now the East Coast tends to have moving assembly line, well not moving, tends to have assembly line production. So you're seeing in these pictures modules side by side in the factory. Some factories have them move end to end down the factory. Most factories on the East Coast, because we're building indoors, we can build from the inside out because it's always summertime in the factory. It doesn't rain in the factory, it's an even temperature. And so as these modules move down the assembly line, everything we can build it from the inside out, which means I can get behind the walls for a longer time. So if you look at the bottom left-hand picture, what you're seeing is a wall that's going up that has no insulation in it yet. You'll see the electrical wires. You should be able to see in those electrical wires, most factories take a fire foam or a fire caulk, and they're sealing around the electrical box where it meets with the drywall, but they're also sealing where each electrical wire goes into that box. Now there's just an aside talking about structure. A number of factories on the East Coast, you'll see those wire boxes aren't just nailed to the 2x4 or 2x6. They're not just nailed to the stud. They actually have a system where it's a supported system, so those boxes don't move. Those boxes are solidly built to the walls. As we move to the right, your grade 1 installation or insulation hang, it's pretty consistent. I mean, that picture shows you're getting a consistent, the person that installs insulation understands exactly what the expectation is. They know how to do it. They do that same thing every day, and they're doing it module by module as it goes. And in the far right module, you're seeing how it's prepped and ready. You're starting to see that roof assembly. Many factories, the standard is using bat insulation, recycled insulation. Many factories will do rock wool insulation. One of the things that as we start talking more about labels, most factories don't have a program that says, hey, I'll just do the water sense. You're going to have to tell them what to do. But the factories are really driven by what their builders' expectations are. So for example, we want to do high performance homes. We might want to do a 2x, we will experiment in some cases. And so we'll take do a 2x8 wall, put in an R30 insulation, manufacturer spec says it might crushing it to that 1.5 inches, and you still have an R27. We'll do the foam wrap on the outside, get to say an R32 wall assembly. How cost effectively can we do that? And so some factories will work with you to play and experiment, but most factories themselves, in and of themselves, aren't having an energy standard. Having said that, there are factories who are doing net zero. For instance, if you Google zero energy homes, Geneva, New York, you'll find a manufacturer there that's doing communities who is building modular in a factory, a small factory, modular zero energy homes, and doing complete subdivisions doing that. I will say this industry is changing quickly. Things are happening fast. New factories are coming up. Money is coming into this industry, so we're going to start seeing, I think, a lot more capability at factories. A lot of factories are learning. Most of them have been going into the commercial side, but they're starting now to do a lot of residential construction, or moving into the residential construction side with a lot more advanced capabilities. So talking about material efficiency, from a green standpoint, one of the things, well, from an economic standpoint, cost-effective standpoint, materials are being purchased in large economic lots. The factories, they're buying things by the truckload, the semi-truckload, not by the straight truckload. You'll see right here in the bottom pictures, as soon as that material comes in, it never sets out in the weather. It's protected while it's on the truck from the lumber yard. It immediately moves for indoor storage at the factory. From a cost perspective, it doesn't get vandalized. There's not the theft that you have from the job site. One of the things that a lot of factories do is when they order it from their suppliers, because they are ordering it in larger quantities, they can have it pre-cut for the size. So for example, we're doing modules that are typically, they're not really 14 feet wide because of transportation and packaging. They're 13 feet 9 inches wide. And by the time we have perimeter bands put on, we usually do double perimeter joists. We can have the floor joist cut to the exact specified length. That may not happen at the factory. That may happen at the mill or the provider for the lumber. If they are cutting it at the factory for the size, say they order 16-foot product in, they'll have the machine cutting it to the exact, or the saws cutting it to the exact length, but the offalls collected and milled for alternative use. You'll see in a slide upcoming, it's OSB or block. It becomes the dimensional lumber becomes blocking for kitchen cabinets. And most of what we do is the waste is segregated and recycled. You'll see that soon. So here we go, that the whole mantra at the factory is to reduce, recycle, or reuse, recycle. And so the first thing is, can we reduce it? As I was saying earlier, can I order materials that are pre-cut? If they're pre-cut, I don't create the waste to begin with. Because I order things in bulk, it might be electrical boxes, it could be any number of things. They're not individually wrapped, they're coming in boxes or bins. We're not getting all of that packaging waste that we typically get at a job site. One of the things I see at a lot of production builders is if there's 2x4s, 2x6s delivered that are not used, it could be materials inside. If somehow an extra light got delivered to the site, they don't take it back. They throw it in the dumpster. It costs more to take it back and reuse it than it does to just throw it away. And they don't care what goes into the trash bins. So materials are just getting thrown away because that's the cheapest thing to do. The other thing on site that we don't typically see is we see one big dumpster. We don't see people doing pre-sorts. It's for a local builder, a small builder, maybe a semi-production builder. It's time consuming. It costs too much money, and it's just inconvenient. So local small builders aren't doing recycling in their bins. To the right-hand side, it kind of talks through the process. There was an organization in the UK that the Waste and Resources Action Program. They studied modular construction in the UK. They found that by using modular construction, that you eliminated about 90 to 95% of the trash that was actually going into the landfills. An example of this in the bottom is OSB. Recycled OSB ends up being blocking, typically behind a kitchen. This looks like it could be a kitchen or a bathroom wall. So here's the recycle aspect of it, the field versus factory. This top left-hand picture, you're seeing a typical job site, lumber strewn throughout the yard, out there to get wet, get rained on. There's the dumpster that's sitting there. It's filled with one of everything. According to a study that the NAHB did, 8,000 pounds of waste is created for the construction of a 2,000 square foot home. And a lot of that is recyclable items. That's wood, that's cardboard, that's drywall, that all ends up in the landfill that doesn't have to be. In the US right now, the calculation is through construction that 40% of all the waste does come from construction materials. But now we can compare it to what's happening at the factory. Now, excuse some of these rough looking pictures, but this is actually what happens in a factory. There are 3 cubic yard bins stored strategically or located strategically throughout the factory, and they're capturing the waste. So it's being sorted as it happens, where it happens. And so you'll see that trash one at the bottom middle, it's pretty empty. When it really comes down to it, very little true waste gets out of the factory. There's one factory in Pennsylvania I know that through their wood waste, they will recycle every piece of scrap down to the point that it gets to be a little 3-inch cube. And it may not be the greenest thing to do, but they actually have a boiler and they burn that in the winter, and that heats their plant in the winter. So it doesn't go into the landfill, but that's how they reuse it. Some of the factories are in farmland, so sawdust, things like that, they get collected to be, for the stables for livestock nearby. Very little does get out to the factory. The factories are being strategic and trying to think how they can eliminate cost by eliminating waste disposal. Water management. energy, you know, EPA Energy Star certified homes where you want water management in the wall assembly areas, roof assemblies, building materials. We are doing finished homes. When we ship a module, inside that module, the drywall is finished, the insulation's finished, trim is completed, flooring may be done, kitchens are done, tile work is done. Water is the enemy of modular construction. So the factory and the builder does everything they can to eliminate that. So on the right-hand side, you're seeing that picture, and that picture is what modules look like when they come out of the factory. That's delivered to a job site. Typically, it's a 6 mil plastic that's sealed on the roof, and in a lot of cases, that 6 mil plastic is cut back off perfectly, laid back down, and used in a crawl space or in a basement as a 6 mil vapor barrier, so it doesn't end up in a landfill. It's being reused. The other aspects of that's how the modules come, so we don't get them wet. The middle picture, what we're trying to show is we're doing the wall assemblies and we're installing windows. In most job sites that I've gone to that are done on, or home job sites where the home is built on site, you can look at 3 sides of that house, and the membranes, the sill pan membrane, the side membranes of a window are all done differently, and maybe not all done correctly. They're not installed correctly. At a factory, you can go to each one of the modules, you can go down the line, and every window is finished correctly, and it's done the same. One of the big aspects when you're really working with new materials or different materials, the product works really well, but it's the failure in the field aspect. If somebody wasn't trained, they weren't told how to do it, they weren't told how to do it consistently, and it's not being inspected, that doesn't happen in the factory. Again, water is our enemy. At that bottom picture, that's just showing a site where what happens is it rains, the truss lays out, it's getting wet, it's not drying out. Nobody's testing it to make sure it's at 19% moisture content before it gets installed in the home. They're installing that, the rain stops, they pick that up, it goes in, and it gets the OSBs applied, and the roof gets completed. That's the way on-site construction happens, the way very differently than the way off-site construction happens. Indoor air quality. One of the things I've been really pounding here is indoor construction. It doesn't rain in the factory. Lumber, when it comes in, is stored inside. It doesn't get stored outside. When we're doing the construction of it, windows assemblies, thermal envelope, the house wrap, it's done consistently, it's done correctly, it's inspected to make sure it's done correctly, and it's basically always done correctly. We're not letting moisture get in. We're having a clean environment. We're not letting the dust that typically happens on the indoors. In most site build construction, it gets muddy. There's drywall dust, there's sawdust, there's any number of contaminants that are coming in. Workers are smoking in the house. It's as they're working. That just does not happen in the modular factory. Each one of those modules, water's never got in, dust is minimized because of the way it's done, cleanup is done on a regular basis, and a clean work environment, and the way they protect the actual work area themselves, remove the dust particles. As a matter of fact, when we're doing constructing of a typical modular home, without doing any additional work, the home comes out, the thermal envelope is so tight upon installation that we typically are always having to have an HRV or an ERV installed because the home is so tight. Toxic reduction or elimination. Most factories, I will say every factory, is using no or low VOC products. If you're a true green builder and you want to get the list, the factory will provide you the list. If it is a low VOC product and you want a no VOC product and you want to specify that, most factories will accommodate that for you. But they have their standards, but most factories will accommodate the customer what they're trying to do. Pounding it again, removing mold. We don't have mold to begin with. We're not that right-hand picture where outside all the lumber was just kind of thrown out for the worker or the framer to pick through it and find what he really needed because it was just thrown in a pile. Indoors, you can see the drywall can be finished. Why there's no ceiling or roof on the house? Because it's never going to rain inside. Indoors, it's always dry. We don't, again, let moisture get into it. One of the aspects is when you're talking about products in the field, if somebody's short a tube of caulk, somebody needs a product, a paint, something like that because they just have to get this house finished. The guy runs out, the punch out guy runs down to the local hardware store or the local home improvement store. He buys whatever he can find and he comes back. You really don't have full control over what's going into that product. That's not true with modular. There's a consistent use of product because they know what they order, they know what they use. They don't buy it by the tube, they buy it by the tank. And there's no unknown products in the home. The factories, they have to warrant the products. They have to know what they're getting into from a liability perspective. So they're studying and researching the products before they're placing them in a systematic way into their homes. The smart growth and sustainable development aspects. Right now, I will tell you that the lower carbon footprint is a big aspect of modular construction. If you think through the process and you're building on site, how many trips over that 19 weeks that it takes to build the average home on site, how many times did the plumber have to drive that 45 minutes from his shop to the site? How many times did he have to leave and go get materials? Now multiply that by the electrician, multiply that by the HVAC mechanic, the framing crew. We're driving all of these people in every one of their vehicles to the site each day. With a modular unit, we're not doing that each day. We're actually taking all the units, doing them, or all aspects of the construction, doing it in a centralized location, one single factory, building it, and then shipping that completed completed piece to the site. We're not making all those trips. Because we have better schedule control, we don't have things slipping and doing things differently where we have to buy products that maybe don't fit. We have budgetary certainty, and as you're doing the smart growth side, as you're developing and planning, modular gives you budgetary certainty because when you sign a contract with the factory and you have it locked in, that's the price. You don't have to worry about lumber costing more, wire prices going up. It's a consistent price, and you can lock that in. You also have the reduced impact on the environment, like we were saying earlier. We're lowering the carbon footprint. We're not making lots of impacts in other ways. And we support well-designed homes. One of the things we haven't really talked about much in this slide is a lot of people think that modular homes have to be square and boxy, and that's not really true. The biggest thing in this industry is a lot of developers get into it and they have a home plan that they want to have in their community, and they say, please modularize my house plan. Well, that's really the wrong way to go about it. You really should start with modular design from the beginning, because you can design and build the features that make modular construction cost effective, strong, and better. You can build those aspects into the house plan so that you can more cost effectively build the house and take full advantage. So you're providing well designed but lower cost, energy efficient homes to the job site. Just wanted to talk, this is just a slide to show some examples of what happens in the field. You're seeing modules in many different ways come together. That top slide is, we do homes on pilings. So along the ocean, on coastal ways, you're seeing hybrid construction happen in that top slide. You're seeing modules that were built and then a large vaulted area that's being built with panels, and it's all being done on pilings overlooking the water. On the right side, you're seeing we typically use lolly columns at the central points. One of the big aspects, and I think we might do a future presentation, but is on modular construction and its differences. We transfer load to the midpoints of the module or of a house, so we don't just transfer to the outside walls. So we do have to support homes with lolly columns, steel beams, etc. But if you look in that module, you're seeing right down that kitchen is finished. Typically the kitchen, the cabinets are in, the countertops are on, the drywall's finished. You're seeing all the can lights in that house. All that is done, ready for the next module to be installed beside of it. You're seeing large openings. There's a temporary support. That's just an example. That was installed by a crane. The middle slide, you're just seeing how the crane is establishing the stacking boxes. Again, like I said earlier, how big of a house do you want to build? All you're really doing is just stacking Legos. We can build that 10,000 square foot house, and we precisely set them with a crane together. And just like you're seeing in that left-hand slide, then we're using a panelized roof assembly on that house. So the workers on top of the roof landing those, they'll place all of those and attach them, put finish the little bit of shingling that's needed, because the rest of that shingling was already done at the factory. So with that, modular construction is a green construction process. Just the construction process itself promotes energy efficiency, both because we're cost effectively building in the factory. We're building houses in a precise manner. We're building it so we have a very tight thermal envelope. We can build to pretty much any standard or any requirement that you request of the factory. You just have to provide it. Because of the waste management that we do, we can eliminate, according to the RAP study, that's 90 to 95% of construction waste does not make it into the landfill as it currently does. You have the ability to specify your materials. So as a green builder, if you have a factory that has a standard and there's 3 items you would like to change, you can typically define what that preferred building material is, and your factory will accommodate you. Indoor construction does remove water from the job site, because the job site is typically indoors at the factory, and you can argue the percent of completion. You'll hear it really depends on the design. As I was saying earlier, when you efficiently design a home, we can make it so up to 85–90% of the project is done in the factory, and so very little work is done in the field for the modules. Some very custom homes, we might get down to where 50, 60, 65% of it is completed in the factory. And that's still great because we're taking advantage of the factory efficiencies, the factory cost, and the speed of construction in the field. Modular construction, and I think one of the big aspects of it is it fixes the failure in the field process. Failure in the field is huge. The building components industry makes a lot of great products, and then they get installed improperly. And it's hard. You're working on uneven ground in the cold and the rain and the heat and the wet, and you're expected to install that perfectly. When that manufacturer had it tested at one of the labs, it was setting in a perfect condition when it was tested. But in the factory, we get to install it in that great ergonomic condition. I'm standing at the waist level, doing the work on a level concrete floor. The temperature is always the same, and I'm not getting rained on. Additionally, modular construction enhances green construction because it's just healthier. I'm not getting dust into the ducts. I'm not creating the ducts. I hate to say this, I've watched laborers at job sites, put the dirt in ductwork, in registers, and that's just things happen in the field that you don't want to imagine happening in the field. We eliminate that kind of these things from happening because doing modular construction, we have the ability to maintain and oversee everything as a process. So with that, that kind of wraps up the initial presentation. If there's questions, I'm sure Brett will start asking. I'll just say with me, again, I'm Ken Semler. I'm a certified aging in place specialist. That's the CAPS. My email is ken@impressivemodular.com. You can go to my website at kensemler.com, and I'm active on LinkedIn, constantly writing and posting on LinkedIn. Lots of articles, lots of postings, lots of opportunities. So with that, Brett, do we have any questions?
Yeah, thank you, Ken. We have a ton of questions. So are you going to be able to stick around? You going to be able to hang out with us for a little while?
Sure. Start
this is
shooting.
great. Well, real quick, before we get into those questions, just a couple things here. Can you see my screen now?
Mm-hmm.
Great.
Yes.
Yeah, so let's go over a couple of the lead items. Ken obviously addressed a lot of the technical aspects, so we're just going to give you some high-level pieces before we get to those questions. And in fact, some of your questions coming in, we might be able to answer as we're going through these. So construction waste management, huge. This is a V for materials and resource credit up to 3 points. It's not required. There's a misnomer about LEED that it's required to do recycling of any kind. It is not required at all. It's a good idea, but it is not required. But it's low-hanging fruit for modular, because the whole idea is that you start out with a baseline based on the number of bedrooms and square footages of what LEED assumes is going to be generated on that site based on data. And then you go down from there, reducing that waste in the first place using strategies, and then you divert the rest to get your points. So you can just see here kind of a simple chart, based on the point reduction, based on your baseline, you can pick up anywhere from half of a credit all the way to 3 credits up to a 60% diversion. And so, Ken, you had a great, I think, a little kind of upside down triangle on one of your charts that I think referenced this, but specifically, let's imagine, this is just an example that's not real. You had 100,000 pounds of waste on a lead reference home, and 70% of it got eliminated at the modular factory. You know, let's just, this is just, you know, an example here. Let's say that, you know, brings you up to, you know, 1.5 points. And then you have 300,000 pounds, 30,000 pounds of waste that could be generated on that site, you know, from the leftovers. And let's say they divert 50% of it from the landfill to recycling. Then, you know, let's imagine that's another half credit. So you're already at, you know, 2 out of 3, and a half of those credits simply just came from the site. As Ken stated, you know, I made this before he made his statement, but if they're reducing 90% on site, you know, you're already pretty much mostly all the way to your lead credits simply just by building modular. And then V4.1, which is still in beta, it's not adopted yet. This is the single family homes program. Look at this, if you divert 50% of 3 material streams, you get 1 point, or 75% of 4 material streams, you get 2 points. So again, imagine if, you know, you just talk to the site and they said, yeah, we're gonna divert all the wood, all the metal, and I'm just using examples, all the drywall, right? We're gonna divert 100% of it in the factory, and we can document that for you. And, you know, there you go. If, you know, that gets you your points here under the new version, which is, you know, allows you this alternative pathway that doesn't require the more complicated calculation that you have to do. So what I really want to drive is that by going modular, it's going to make you easily hit this point. And the fact that if they're documenting these waste diversions on site, then it helps it out even more. As far as durability management, I mean, again, we're going to be looking at the Energy Star Homes version 3 water management checklist, and we can share that out if you need it. It's required. It's not required for Energy Star, but it is required for LEED. And again, as Ken pointed out, just so many benefits, such as especially reducing exposure to moisture and water damage, which is a requirement of Energy Star 3. That's already taken care of for you on the project, and so it just makes it super easy. And as Ken pointed out, you know, all that third-party on-site verification that can be done right in the plant makes it really easy. So there's a credit for LEED MR durability management verification where the Green Rater actually has to come in and verify these things are done. And so that could easily be done through a good photo documentation process that could easily be implemented in a factory versus on site might be much more difficult, especially I assume if you have that conversation with the team ahead. And so that's again just verifying all the appropriate water management installs are done in the factory. Could be done much easier. And then lastly, annual energy use. And again, that goes back to what Ken was stating, like oftentimes, you know, grade 1 insulation is either required or at least grade 2 is required when you have exterior insulation. And so as Ken mentioned, it's much easier to do that, especially if you're calling out fiberglass bats, which make it nearly impossible to do. Much easier to do that on the site and verify it's done before the drywall goes up, or in the factory, should I say. And also all those air sealing measures and metrics can be done much easier in the factory, helping with your overall energy performance and HERS rating performance on the site. And so there was a question here, Ken, and maybe I'll kick it over to you specifically. You know, as far as these inspections go on site, but can you just talk a little bit more about, you know, what site inspections look like? Is blower door testing being done for air sealing, or is that typically just more visual?
No, so and a lot of times it depends by state what you're trying to do for a label or a program. But so for example, in Maryland, blower door testing is required. And so once the house is completed, we have to work with an energy auditor from the beginning, get him the information, and then they come out and do a blower door test at the end. Maryland requires a 3 ACH 50 for every house. So there is testing in Maryland. We get into other states, and a lot of times it's either by locality or whatever. They're looking for a certain HERS rating. So that's really testing themselves, you know, being local testing, and it's supported program by program. Massachusetts is a big state for that with the factories for their energy program. But on site, aside from an energy perspective, the additional inspections that happen, just keep in mind anything done at the factory is inspected at the factory. So that insulation install that Brett was just talking about, from a true inspection process, that's taken care of. Any exhaust venting stuff like that, that's all taken care of at the factory. But if it's done in the field, or done in the field, any of the connections that have to be done, so that could be electrical, that could be plumbing, that's mechanical. A lot of the mechanical work, which we really didn't get into, is Modular will do, like, say for some systems, they'll do the boots and registers, they'll do cold air return, chases. That will be done in the factory, but the factory typically does that based on the input of an HVAC contractor or subcontractor from the site, telling them where they should be located and the sizes. The factories, I know factories are starting to experiment, and this is again being driven by builders, but it might be driven, to the Detson system or the Unico system. Some of these small steel duct systems, I see a lot of promise in being done. Some of the factories are doing split systems. So we're seeing some factories do pre-install, I hate to say a Mitsubishi system or whatever, a split system at the factory, and they'll actually install the compressor in a niche on the exterior, so, or on the rear of the unit, they'll have a rack that's already pre-built, a shelf. So it's 100% installed at the factory, 100% done, so you don't have to do anything on site.
Great, great. Thank you so much. Well, let's we got a lot of questions coming in, so let's get into the official Q&A section. Before we get to those questions that are coming in, for those of you who want to get your CEUs, take that survey that pops up when we close the session. If you miss it, it'll be sent to you an hour later. Even if you don't need CEUs, please take it. We certainly appreciate your feedback. For those of you watching this in the future, I'm not talking to you live right now. Take that 10 question quiz with an 80% passing rate to pick it up. To find that quiz on our site on YouTube, go ahead and click the YouTube link, and then on the side, go ahead and click Show More, and then on the right side, you will see something that says, do you need your CEUs or take the quiz? Follow the link and follow the instructions. And again, as those questions are coming in, a huge thanks to our board of directors, all of our members, our volunteers, and a huge thanks to our top tier sponsors, Mitsubishi Electric, Build Equinox, Serve 2, and Ream. Big thanks to all of them for allowing us to do what we do. So Ken, there are a ton of questions coming in about just kind of like shifting and damage during travel. And I don't believe you addressed it, but even if you did, could you just reiterate, what are your thoughts on that? Can insulation shift? What can happen during the traveling process?
So I guess there's a couple aspects, and we typically, if you're doing bad insulation, I guess that's one of the questions is, does it shift? Does it settle? I'm not going to say it doesn't. I'm going to say we typically haven't seen that. When we've had to go back into a wall for another reason, we haven't discovered that in practice. But there are things that happen. We are shipping 14 wide, 16 wide modules down the road. 99% of the time they get there safely without an issue. Occasionally there are things like tree limbs or scraping where things happen and damage has to be repaired on site. From a water aspect, as I showed in the one slide, it's 6 mil plastic is placed on the top. They go under a tree, that plastic is torn. It might be a day or 3 until that module is set on site. There could be a subsequent rainstorm in between. Typically, it's part of the driver's responsibility and the builder's responsibility to do an inspection upon delivery of those modules to the site. And so that damage, if it's say it's on top of the roof, does it need to be either repaired? Is it simply a tape repair to make sure we're again weatherproof, waterproof, or is it getting a tarp? And it's a joint effort between the builder and the factory or the driver to do that. I will say in practicality, the drivers typically don't have ladders, and so it's good for the builder to have a ladder upon delivery of the site to do a full inspection to make sure you remain watertight until the job's set.
So speaking, just as we're talking about travel here, there was a question about like really difficult to reach areas such as a walk down cabin. I thought I've heard of people helicoptering in Modular once in a presentation we did, but any quick thoughts on that?
So it really comes down to one, you need to inspect the site, and just like you say, Brett, there are Sikorsky helicopters that can raise 26,000 pounds, and if you have a remote site in Wyoming and you want a pre-built home and you want it within days or weeks instead of taking 2x4s on mule trains to the site, you could use a helicopter, and it is possible based on the ratings. I've never done it. We do barge houses to islands, get cranes to islands. That's not unheard of, putting them on ferries and barges. But the biggest thing is ensuring we can't get a modular home everywhere. That is a bottom line. We in the cities, we have power lines. We have to be careful with cranes, OSHA safety with power lines. But there's other things that we can do. Sometimes we actually, in some areas, do what we call roll-ons, is where we mechanically move the modules without a crane, and we can go under the power lines. So it's just having the expertise and the knowledge based on the area, but there's a cost to the delivery, and you have to also pull that into the budgetary side of the equation, and does it make sense? Modular is going to be faster. Modular to me is going to be a better quality product, but is it going to be cheaper? Is it going? That's what a lot of people have to determine.
So a question here, do you ever work directly with homeowners that have some construction experience and plan on subbing the project themselves?
From a personal aspect, we do. Factories typically don't work directly with consumers, or they only work with builders. Again, they're a manufacturer working with their distributor, their builder. We personally do that, but because we actually have a support capability to make sure that they succeed. And so, yes, the answer is yes.
Well, and following up on that, then, is there a specialized builder or trade that needs to be, a training or something, kind of mentoring, or how does that work for builders?
So, I'm not trying to sound too. We have a franchising side of our house because I love this industry. I'm probably one of the biggest proponents for this industry. But as an industry, we don't really have a great training program. It's a builder on-the-job training, and so with us, we have the experience being in 42 states that we've basically figured out how to scope everything. We have the documents. We work with subcontractors. We train those subcontractors on how to use modular, and that's how we succeed in all places. I'm just going to use as an example, electrical. An electrician who's never done a modular home doesn't understand the process, and there's nobody to train him. He might take that wire coil that has again, this is very much an insert tab A in slot B process. The factory puts a wire coil there. Very simply, they just put the circuit number at the end of the wire and let you install that into the panel box. But an electrician might shorten all those wires, and he just cut the code off of it because nobody told him the code was on the end of the wire. And so it's not hard, but there's a process, and it can be very costly if you don't understand the process.
Yeah, thank you. So I don't think you meant to say this, or at least that's the way it is, but the question is, is there a reason why site built is less regulated than factory built?
Well, so what I was trying to get to, and that is, so I'll just use an example. I'll pick, don't want to pick on Nebraska, but in much of Nebraska, there's no building permit office, there's no inspection office, there's nobody. You can build a house on your ranch, and nobody will inspect it. So if you have a builder who has been there for years, there's no say builder licensing. So there's no way to confirm that it was built to local building code, built to current building code, because there's no inspectors. If you build it using modular construction, Nebraska say has a state building code, and it will be inspected by the third party at the factory to in fact ensure that module was built to the state building code in place. So what I was just trying to say is, as a module, we can make sure we conform and we inspect that our modules are built to the current building code in place at the location it's going, whereas site building doesn't necessarily do that. In Maryland, I guarantee you it will be inspected, there will be permits, the inspections will happen ad nauseum, and in Nebraska, you will never see one inspector. on a site-built home.
Great. Let's talk a little bit about architects and designers. Do they still get the same level of specification control? So for example, can they choose their preferred insulation switches, etc.?
So, I'm going to say the level of specification control may vary by factory, but what most architects, there's some great architects in modular. They understand the process, they understand the design, they understand the different ways we do loading, and they design it within those parameters. And but usually most people find there's a practical limit. And so if you're doing super high-end work, and to me, there's no glory in hanging installing 2x4s and hanging drywall, and that's just not. There's no glory in that. If we can get you to a shell more quickly and get that part done, and you're an architect and you're specifying specific finishes and kitchen, cabinetry, countertops, maybe even lighting, but we can do all the prep work. I think some architects could find a happy medium, not just say modular doesn't have a purpose because I can't take it to the level I want.
We're going to have you back on later to do a session just for designers and architects, right?
That's what you told me.
Right. Now it's recorded. Some other questions here. Have you done any commercial office? What are the key differences between residential, commercial, and maybe I could even throw in the mix, multifamily and mixed use, just some of the high level differences?
It's really from a factory perspective. There's a lot of aspects. So most factories that do residential construction primarily focus on residential construction. They will do some multifamily or commercial. From a hospitality perspective, Marriott about 4 or 5 years ago decided they want to do every hotel that they do as much as possible. They promote their franchise owners to use modular construction. And that really created a big wave because of the capacity in the industry. I myself didn't realize how many hotels Marriott builds each year. But they're trying to build everything because it makes sense. Think about it. There's a hallway in the middle, two rooms on the end, and every module can have modular makes sense to do this. When it comes to like offices, doctors' offices, other offices, modular does that. We're seeing it more and more just because of the efficiencies. One of the areas that I see coming out, I'm going to say, is the build to rent market. Is when you start doing commercial work, commercial definitely is booming for modular. But when you can start taking what I see a lot of people are struggling when you pencil commercial projects is there a value for speed? And if I can have my project 2 months, 4 months, 6 months sooner, and that's where Marriott fell in. There was a project that it would have taken 18 months to build on site, and it could be done in 6 months with modular. Well, that's 12 months of occupancy and revenue faster. That they may have paid $3 per square foot more for the module or for the modules, but that was more than made up for in the whole business aspect. And because they had an ability to put a budgetary number to the speed, they were doing modular math. They could assign a value to speed, and that worked real well. And so if you can do that in commercial, it really helps the modular projects pencil.
Great, thank you. With more people looking down the line at the life cycle of buildings, right? Like where buildings are going to end up at the end of their life, right? Because every building potentially has a life end, or could have a life end if it needs to be moved. Have you seen a push for planning for deconstruction, material reuse? Maybe we could even go as far to say, cradle design, or end of life. What are buildings or our homes being designed and built to be deconstructed and reused somewhere else somehow?
So within modular, there's two aspects, and I will tell you in the permanent modular, I would say that's in its infancy, that thought process to be done. But there is a relocatable modular process that's in its entire life. For example, we have an aspect on our commercial side. We do educational buildings, so we have a town or a school board that will do multiple like 6,500 square foot buildings. These 6,500 square foot buildings contain 8 classrooms, restroom facilities, faculty facilities, janitorial facilities, and that's all contained in a 6,500 square foot building, 9 modules. It looks just like regular construction, but 5 years from now, school populations change, and we may have to take that down, relocate it, and reinstall it at a different school. And so we do that. And so that's it's specifically built to be relocatable. It will have a frame with wheels under it built to commercial construction code for the educational facility. Permanent construction, again, I'll go back to, that's in its infancy for that side.
Great, thanks. Have any projects combined a separate site-built exterior wall system such as ICF with interior modules?
So I'm not familiar with an exact project. I know that could be done. Again, we do lots of hybrid construction, and so it's finding the project where that makes sense to do. So if you have a project where economically or from a requirement standpoint that's what needs to be done, I don't see any issue with doing that.
Great. Let's talk about HVAC. Is that done in the factory? Is it done on site? A little bit of both. How do you handle that?
Yeah, I mean, I was saying that a little bit earlier. Is it really the factories will do? They'll either do boots and registers and returns to find you, because the local HVAC guy or subcontractor specified it, and it was built to that at the factory. And then he's doing the trunk lines, he's doing all the compressors, he's doing the air handlers, he's doing all that work on site. Historically, that's the way most modulars have been done. The mechanical aspects have been done on site, but the factory's technology is changing, things are improving, the ability to install these systems at the factory efficiently, it's coming. And the demand by the builders and the consumers are starting to bring that. It's what can be done efficiently in the factory, and that's why I brought, name like Detson and Unico are two good examples of a sealed duct system that also make it easy to install at the factory and complete on site.
You talked a little bit about a plant that's making, I believe, zero energy homes. But besides the actual end product, can you tell me a little bit about plants that are moving towards use of renewable energy for actual operations, or going all electric so everything could be offset by renewable energy?
So there are lots of plants in the United States, and like I said earlier, there's lots of ones starting right now. So I know that plant in New York, they're making efforts to make their plant not just do zero energy construction, but to move to be a zero energy plant themselves. There are plants who are adding solar aspects to their so they won't be doing 100% renewable energy, but they're adding the solar farms, the solar, in the parking lots. There's, I know, a factory that's actually getting ready to be built, and that's their goal, is to be a zero energy factory. They're not in operation yet. So I think our industry is coming around to this, but it's plotting.
So obviously the big question is on everybody's mind is costs, and where the cost savings are, and if there are any cost savings. Some questions coming in are, what's the overall cost comparison on average of site built versus modular? And I would suspect the theory is that, all of this missing labor and labor costing a lot can kind of be diverted by doing it at the plant, is my understanding. So maybe you just can speak to us in general about cost to the extent that you can.
So that's a great question. And it really is geographically where you're located. Modular makes really good sense. I will tell you, in the place where the most sophisticated, the biggest capability for modular is typically the Mid-Atlantic, Midwest, Northeast, and that's because you can take say, I'm going to say Central Pennsylvania has the most amount of factories of the states in that location. Northern Indiana has a lot of factories, but you're taking a manufacturing location, lower cost of labor, and then you're transporting it to the bigger cities. So in Pennsylvania, you're building it in Pennsylvania with an $18 or $20 an hour or worker, labor, staff person, and you're shipping that to New York where there might be $85 an hour for a carpenter. And so we're taking that lower cost and we're shipping it, and you might save 35% building it modular, 30%. You have to do your project and see. But I can tell you that if you also build it in Pennsylvania and ship it within Pennsylvania, it might be very close to being a break even, the same number. You're not going to see a huge cost savings. But the benefits of modular aren't just price. It's one, how fast can you get it? Can I get it 3 months faster, 4 months faster? It's the value, the quality that you're going to get, and the energy efficiency, because it's really hard to build it in the field to be as energy efficient as it is being built in the factory. But I would say we're usually break even, but we're not going to. What I think a lot of people confuse modular with, again, the M words, is they hear the M words and think mobile home, manufactured home, and they think, oh, this is going to cost half as much. It's not going to cost half as much. Again, maybe Pennsylvania to New York, 35% savings. Rural Pennsylvania, break even, maybe 5%, but you're building it for different reasons.
So we're starting to see a shift in certain areas to more of a slab on grade construction. I mean, reducing cost, reducing energy loss. That's, you have to heat and cool that basement, and then a lot of times we're talking about moisture, mildew, water damage that eventually inevitably occurs in basements. But my understanding is that modulars and slabs, and actually we're working on a very specific project in GR where we're running into this now, they don't necessarily go hand in hand. Can you speak to that a little bit more with modular and slab on grade and what you're seeing out there?
So, yeah, and I think this is one of the biggest reasons that it's a struggle for production builders to convert to modular construction, is really for this reason, is it's much more cost effective to build slab on grade if you're going to be doing building on site. If you're doing modular and you want the full benefits of modular, if I don't have a floor that I'm shipping, how do I finish a kitchen and put cabinets in? How do I finish a bathroom and put the tubs and shower and fixtures in, the vanities in? I need a floor to assemble to gain the full efficiencies of factory construction. If I'm just building a shell, and so example, we do modular garages where we know on site there's going to be concrete. We build the walls, we build the roof, we actually deliver it and ship it to the site. We put a temporary structural floor in for shipping, and we tear it out, and the slab for the garage is poured, and we do that. But that's not, it's time effective, but it's not cost effective to do that typically. And so it's being done because of the time aspects of it. If we would take, and we've had this discussion with developers, how do we ship the floor and then you do a sill plate around the perimeter of a slab on grade and install that, so we can do the more complete factory install, but now I've just paid for 2 floors. And so does the project support that? Can you do that? Do you get the efficiencies of the slab on grade foundation, the speed? And that's what, and so then you're figuring out where you have maybe floor access panels, or do you create what we call a utility pit, run your utilities to that within the slab? Again, there's a number of things in the thought process, but it just has not penciled out in any project that I've seen to date to try to come up with a slab on grade modular project.
And I think last question here before we wrap up. Can you speak a little bit about additions? What opportunities are there for using modular in additions?
Yeah. So, and we do this. It's and again, some of it plays into cost and how they pencil. And so there's a regular addition. You want to do an addition on your home, and you have to specify it. You have to do all the calculations because we want to make sure everything lines up: the floors, the walls, the roofs. But you get that specific measurements and calculations done. We've typically seen in most areas, now they usually have to be large additions to pencil, 600, 800 square feet minimum to start. for a conventional addition, but that works. We can at least be cost effective. We can be fast, especially in a lot of markets. Prior to this current economic situation, or it was taking somebody 6 months, 8 months to get a remodeler to come in and do an addition. Then there's the aspect of it for the seniors. Mom falls, breaks her hip. She can't move back into her home. She has to move in with one of their adult children, and they need to do an addition for her. But in that case, you're really not penciling or budgeting to the local remodeler guy. You're saying, hey, mom's going to be in a home that's costing me $9,000 a month, and it's an expense, and she needs to move in with me. She needs to be with me and my family. After a year, say you pay $100,000 for that 600 square foot addition, it was easily worth it to you because mom is now with you. It's a different priority, and you're costing against the expense of her being in a home in the interim. So, two different aspects of the purpose and use for a modular addition.
Great, Ken. Well, I do not see any other questions here. Oh, actually, yep, one slipped in here. Can you just talk a little bit about, are there any benefits just inherently of stick versus modular, as such as modular being more resilient to, storms, calamities, tornadoes, hurricanes, you name it?
No, a great question. We did a lot of homes in the Northeast with Superstorm Sandy when it hit New Jersey, New York, into Connecticut. And I still remember a picture one day where, and it wasn't our home, it was I'm going to say a quote unquote competitor home, but they had installed the modular home, and 3 days later Superstorm Sandy hit. And the next day, they had somebody, a helicopter news agency had flown a helicopter, and the house right beside of the modular house totally collapsed. And that modular home, who had just been installed, was almost perfect, barely lost a shingle. And the site-built house beside of it had collapsed. But think about through the tornadoes, flooding, hurricanes, modular is we're taking each module and putting each module together. So it's structurally, it has to go travel down a road at 65 miles an hour, get lifted by a crane. It's structurally put together much tighter. Instead of using caulk, we're using foam seals. We're using lag screws. We're using screws. I mean, the house, we're doing the loads. We're using hurricane straps already, so that we have a continuous load path. We're just building these homes so much tighter, so much better, that they by combining lagging and screwing each individual module together, it's a much tighter, much better able to take the storm. And there is another program called the Fortified program that we've actually been working with, based with the insurance agencies, the insurance industry, is because you can get a 10% discount with us just doing a few things. You can get a 10% discount on your homeowner's insurance if you comply with that program. And modular pretty much complies with a lot of it right now, but it's just figuring out the field inspection aspect of the final installation so you can qualify for that program.
Well, that's great. That's yeah, thanks. That's very helpful. So, Ken, we are at our time. Just real quick, I know it's displayed on the screen, but can you just remind everyone where they can go to learn more?
So yes, appreciate that. My email address is ken@impressamodular.com. I would encourage you to go to kensemler.com, learn more about modular construction at impressamodular.com. And I am super active, hyperactive on LinkedIn. If you are a member of LinkedIn, please, by all means, you probably found your invitation there. I would encourage you to connect with me. Enjoy talking modular, and I'm happy to answer questions if you message me.
Yeah, I second you there, Ken. Everything you've sent out, it's been very enlightening to me to learn following you there on LinkedIn. So I definitely want to second that. Make sure to check them out there, follow them there. Get plugged in. Ken Semler with Impressa Modular. Thank you so much for your time. Have a great rest of your week, everyone. And, hope to see some of you all in person someday. Make sure to stay safe out there, follow all the protocols, and we can get through this fast and be done with it. So thank you, everyone. Take care.
Thank you. Thanks, everyone.